Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the reaction type. The starting material is 1-iodo, 2-methylcyclohexane reacting with H2O, a polar protic solvent nucleophile. This is an SN1 solvolysis reaction because the substrate can form a stabilized carbocation. Moving on to the next step. Determine the first intermediate. When iodide leaves, a secondary carbocation forms at C1, the carbon that bore the iodine, adjacent to C2 which bears the methyl group. This gives a secondary carbocation option, D, which is the 2-methylcyclohex-1-vial cation, secondary. This is an expected intermediate. Moving on to the next step. Determine if a 1,2-hydride or 1,2-methyl shift occurs. The secondary carbocation at C1, adjacent to the methyl-bearing C2, can undergo a 1,2-methyl shift, migrating the methyl from C2 to C1 generating a tertiary carbocation at C1 with the methyl now on C1. This gives option B. Wait, let us re-examine the structures. Option A. Positive charge on the exocyclic carbon bearing the methyl group. This appears to be a primary methyl carbocation. The plus is on the methyl carbon itself, i.e., a primary carbocation on a CH2 plus group attached to cyclohexane. This would not be an expected intermediate because it is a primary carbocation, which is highly unstable and would never form preferentially. Option B. Tertiary carbocation at C1 of the ring with methyl also at C1. This is the rearranged tertiary carbocation formed after a 1,2-methyl shift. This is expected. Option C. Protonated alcohol, oxocarbenium protonated water, at C1 with methyl at C1. This is the intermediate after water attacks the tertiary carbocation before deprotonation. This is expected. Option D. Secondary carbocation at C1 with methyl at C2, the initial carbocation after iodide departure. This is expected. And for the final step, identify the non-intermediate. Option A shows a primary carbocation, positive charge on the exocyclic methyl carbon, i.e., a CH2 plus group attached to cyclohexane ring carbon. Formation of a primary carbocation from a secondary one is not expected. The rearrangement always goes toward greater stability, secondary tertiary via methyl shift, never toward a primary carbocation. Therefore, option A is not expected to be an intermediate. D forms first upon ionization. B forms after 1,2-methyl shift giving the tertiary cation that explains the product. C forms when water attacks the tertiary cation and is deprotonated to give the product. None of these involve a primary carbocation. Therefore, the correct answer is A. Therefore, the correct answer is option A.